In this video, we will understand about service feature in Angular. The service feature in Angular is closely associated with dependency injection design pattern. So we will first understand about what is dependency injection. We will first see what internet has to say about dependency injection, and then I will start my explanation. When we search for dependency injection in internet, we get the Wikipedia link as the first link in the search result. As per Wikipedia, dependency injection is a design pattern in which object or function receives other objects or functions that it depends on. It further states that it is a form of inversion of control. Dependency injection aims to separate the concerns of constructing objects and using them, leading to loosely coupled programs. Let me also read out the first problem that dependency injection solves. How can a class be independent from the creation of the objects it depends on? Reading all these statements for the first time might be an overload of information, and there is difficulty in grasping whatever is being conveyed. In this video, I will try my level best to clarify what dependency injection means. After going through this video, we will come back to these statements again, and we will see if we are able to read and understand these statements. The explanation provided in this video uses TypeScript classes within an Angular application, but the explanation provided in this video can be applied to any object-oriented programming language that uses classes and functions. A complex application results in having multiple classes. A function in one class can call another function in another class, and then that function can call another function in another class, and it may go on like this. Let me represent this with an example. Let us consider a class named class A which has a function named process. Within the process function, there is a need to call action function available in class B. Within the action function, there is a need to call convert function available in class C. Two Angular components wants to use the process function available in class A. Components are specific to Angular. From the programming language perspective, we can consider them as two separate classes which wants to use the process function in class A. When implementing these classes, it should be noted that we should create only one object of class A, only one object of class B, and only one object of class C. This is the requirement that needs to be implemented. These example classes provided here are a common scenario in any complex application. I am going to implement these classes with respective function calls. I have created a new Angular application to demonstrate this problem. In the src/app folder, I have created three files: classa.ts, classb.ts, and classc.ts, with each file containing the definition of the respective class. The three files are open in the top section of Visual Studio Code adjacently. In this Angular application, I have created two components. In the bottom section, I have opened the two classes of the two components. The left hand side contains component 1 and the right hand side contains component 2. We will look into the components in the web page. We can see two boxes. First box represents the first component and the second box represents the second component. When the Angular application is started, the classes for these components are internally created and displayed in the page. Each of these two classes wants to use the process function of class A. Class A, class B and class C is defined with export keyword so that it can be imported and used in other TypeScript files. Each class has a constructor and it is defined with a console log. The console logs are included in all the constructors and functions, which will help us to know about the object creation and function call during runtime. Class A contains process function, class B has action function, and class C has convert function. For now, don't worry about the commented lines in class B. These are the code snippets which I will be using during my explanation. Class B is dependent on class C, hence the import of class C is included in class B. Class A is dependent on class B, hence the import of class B is included in class A. We now have all the classes required with its respective function defined. We can see function call is not implemented anywhere, which is what I will start including one by one. In class B, within action function, the convert function of class C should be called. For that, first I have to create an object of class C, and then in the new object created, the convert function can be called. Class C object can be created within the action function by including a local variable definition and using new keyword with constructor. Based on this local variable for class C, I can call the convert function. I am uncommenting the lines to denote how the code will look like. I would like to help you recollect here that we need to create a class C object only once. If these lines are included within this function, then a new object will be created every time when this function is called. Hence, we cannot go with this option. I am removing the lines that I uncommented just now. Another option is that we can define a property for class C in class B. The object for class C can be created within the constructor of class B and assigned to the property defined above. Now that class C is available as property of the class, we can call the convert function in class C using this.classC.convert in action function. In this scenario, every time a new class B object is created, a new class C object is also created, and we don't have control on the number of objects created. Hence, I don't want to go with this option. I am removing the code related to this option. Another option is to make the class C object creation outside this class and getting it passed as constructor parameter when class B object is created. In the constructor of class B, I am defining a private parameter of name class C of type class C. In TypeScript, the inclusion of this constructor parameter with access modifier considers that a property named class C is present in the class with data type as class C, and it also means that class C property is assigned with the class C object that is passed as parameter. I have included these lines to indicate that the inclusion of the constructor parameter is equivalent to having these two additional lines. As these lines are not required, I am removing these two indicative lines. To ensure only a single object of class C is created, I am trying to postpone the creation of class C object, and I am currently pushing this responsibility to whichever class that is going to create class B. Now that we have access to class C through this constructor parameter, we can call the convert function within the action function. In action function, I am including the statement this.classC.convert. This statement uses the class C property of class B to call the convert function. Now changes required in class B to call a function in class C is completed. Next we will focus on class A. In the process function of class A, we need to call the action function in class B. I'm going to make similar changes like whatever was done in class B. In the constructor, I am including a private parameter for class B. Then within process function, based on the class B property, I am including this.classB.action to call the function in class B. Now changes in class A to make a function call to class B is completed. Next we have to make changes in component 1 class to call the process function of class A. As mentioned earlier, component 1 class gets automatically loaded when the Angular application is started. We need some place within this component to call the process function of class A. I am choosing to include it in the constructor of component 1 class so that it gets automatically called when the Angular application is started. Now I have to create the class A object, only then I can call the process function. Within the constructor, using let keyword, I am defining a new local variable named class A with data type as class A, which is assigned with the creation of a new object using class A constructor. This statement is resulting in compilation error as we need to provide a class B object as parameter of class A constructor. To handle this, in the previous line, I am defining another local variable named class B and assigning it with the creation of a new class B object. Now in the next line for the constructor of class A, I can pass the local variable class B as parameter. With this change, we can see that the creation of class A constructor does not have compilation error now, but we have compilation error in the constructor of class B. Class B constructor requires a class C object as parameter, so I am creating a new class C object in the previous line and assigning it as parameter of class B constructor. When typing the code within the constructor, I have imported class A, class B and class C. We can see the respective imports included in the top of this class. Now that we have got the class A object created, we can include the last statement of the constructor as class A.process, which will call the process function of class A. Here, class A represents the local variable created above. Now we have completed all necessary coding required to call process function of class A from the constructor of component 1 class. Now we will understand how this code will work in the runtime. When the Angular application is started, the component 1 class gets loaded. When the component is loaded, the constructor is called. Within the constructor, in the first line, class C object is created and its constructor is called. The control execution flow goes to constructor of class C, and this will be the first statement printed in the console. Let me copy and paste this console log in a notepad so that we can compare this with the console output in the browser. Then the code execution flow comes back to component1 class constructor and the next line is executed. Class B constructor is called I am including the respective log in Notepad. Then class A constructor is called I am including the respective log in Notepad. Then process function in class A is called I am including the respective log of process function in Notepad. The process function in class A calls the action function in class B. I am including the respective log of action function in Notepad. In action function, convert function in class C is called. I am including the respective log of convert function in Notepad. Now, when the Angular application is started, these are the logs that are expected to be printed in the browser console. I am saving all the files which will compile and reload the Angular application in the browser. In the console window of browser, we can see the logs printed. I am placing the Notepad and browser console adjacent to each other so that we can compare the output. We can see that the lines in the Notepad matches with the lines displayed in the console, which means that all the necessary objects are created and the respective functions are getting called as expected. Now we have the complete code that helps us to understand the problem that dependency injection is trying to solve. Let me explain about the problem associated with the code that we have implemented. The objective of the component1 class is to call the process function in class A, but the component class is forced to create objects of class B and class C for constructing class A. Component1 is not going to call any functions in class B and class C, hence it is not necessary for component1 class to create objects for the dependent classes of class A. Consider the scenario if class A is even more complex and depends on 10 other classes. Then component1 class has to be included with lines of code that creates objects for those 10 classes in the constructor. Now the component1 class is tightly coupled with the dependent classes of class A. If I represent this scenario in a diagram, here I have component1 class and then I have the classes class A, class B and class C. The component1 class is dependent on class A is dependent on class B and class B is dependent on class C. In the constructor of the component1 class, we are creating objects for class B and class C, hence component1 class is also dependent on class B and class C. The arrows included represent close association between the classes. In other words, it is also called as tightly coupled. We can say that the component1 class is tightly coupled with class A, class B and class C. Actually, component1 class wants to be associated only with class A and there is no need for it to be associated with class B and class C since it is not using any functions in class B and class C. In a complex application, the lesser the tight coupling between the classes, the easier it becomes to manage the application code. Given this scenario, if we make it possible in such a way that component1 class is made to be associated only with class A, then it is called as loose coupling. Loose coupling means that a class creates an association only with the classes that it actually requires. Let me highlight one more problem. Earlier in this video, I mentioned that we are going to have two components. The second component class, component2, also has the need to call the process function of class A. To achieve this, then we need to include a constructor in component2 class containing the object creation of class C, class B and class A. Only then process function can be called. So any new component that wants to use class A should be included with a similar constructor. Now we are violating the single object creation principle, and we are ended up creating the objects for each component class that wants to use the process function. Let me highlight the two problems that we are trying to solve. The first problem is tight coupling. The second problem is that we are not able to control the creation of dependent objects. Dependency injection design pattern helps to solve these two problems. Now I will demonstrate how dependency injection available in Angular helps to solve these two issues. In class C.ts, above the class definition, I am including @injectable. While typing this, I am selecting injectable from the drop-down, which automatically imports the injectable class from @angular/core folder. After @injectable, I am including brackets, and within that I am going to pass an object having a property named provided in with value as root. Injectable is a built-in decorator available in Angular to denote that this object can be injected into another object using an injector. Later in this video, we will look into detail about the terminologies related to the word inject. I am copying this injectable line and I am going to paste it above class B and class A. I am also including the necessary import of injectable decorator in each class. In component class, I am commenting all the lines within the constructor. Then as constructor parameter, I am including a private parameter of name class A of type class A. Now as class A becomes a property, I am calling the process function by including this dot class A dot process within the constructor. With these changes, the dependency injection implementation is completed. I am saving all the files. In the browser, after the page reload, we can see that objects are getting created and the functions are called. Now, in order to use the process function in the second component, I am copying the constructor of component1 and pasting it within the component2 class. Then within this constructor, I am calling the process function by including this dot class A dot process. I am saving the file. After the page reload of the browser, we will look into the console window. We can see that the three objects are constructed only once. These three function call lines are from component1 and these three function call lines are from another component. Class A, Class B and Class C is getting created only once, even though it is used in two components. This makes it clear that we have solved the object creation problem. Let me go back to Visual Studio Code. In component1 class, if we now have a look into the constructor, we can see that we are using only Class A. We now don't have reference to Class B and Class C. The same is the case with component2. We have also solved the tight coupling problem. Using dependency injection pattern supported by Angular, we have solved both the problems highlighted earlier. Let me now explain how dependency injection and how this @injectable decorator works in Angular. Angular has something called as an injector which gets loaded when the Angular application is started. The injector contains a registry of objects and initially it will be empty. When component1 class is loaded, its constructor is called. For execution of the constructor, it needs to be passed with class A object. Now the injector checks if class A object is available in the registry. As initially it will not be present, it creates a new class A object using the constructor of class A. Then the injector checks if class A contains the injectable decorator. Before looking into any object, the injector first checks if the class contains the injectable decorator. It will proceed with further steps only when this decorator is present. If it is not present, it results in an error. The constructor of class A requires class B object as parameter. Now the injector looks in the registry for class B. Class B is not present in the registry, so it tries to create class B using the constructor. The injector checks if class B is injectable. As it is injectable, it proceeds ahead. The constructor of class B requires class C object as parameter. Now the injector looks in the registry for class C, which will not be present, and it tries to create class C using the constructor. The injector checks if class C is injectable. As it is injectable, it proceeds ahead. Class C constructor does not have any parameter, hence the object will be created and stored in the registry. The injector can now create class B object by calling its constructor, passing class C from registry as parameter, and stores class B in the registry. Next, the injector can create class A object by calling its constructor and stores class A in the registry. Now that class A object is created, the constructor of component1 class gets executed. The class A reference within the constructor will now have a valid object and the functions work as expected. After all these steps, component2 gets loaded. When the constructor of component2 gets called, the injector looks for class A object in registry. Now it will be present in the registry, hence it provides the respective object from the registry with which the process function will work as expected. Any other component can include class A, class B and class C in the constructor, and it will be provided by the injector from the registry. If we look into our code now, we don't have any lines that creates object using new keyword. Without writing any code to create dependent objects, the objects are created and it gets automatically included through the constructor. This is why the term inject is used here. Since dependent objects are created and injected by the injector, this whole process is called as dependency injection. Angular uses injector as a mechanism to implement dependency injection. Angular uses the term service to represent the injected object, hence class A, class B and class C are all services. Hope the explanation provided in this video helps you understand about dependency injection. This design pattern is also called as inversion of control. This means that the responsibility to create objects is inversed. Instead of component constructing the dependent objects, it is handled by the framework. Let us now look again into the documentation from Wikipedia for dependency injection. I have presented the same article content without including the highlighted lines. Pause the video here and try reading the entire first paragraph and the first problem that dependency injection solves. I hope the explanation provided in this video helps you understand these lines and understand what dependency injection is all about. Whatever dependency injection demonstration provided in this video is applicable only to Angular. For other programming languages, look out in internet for a framework that is available to implement dependency injection. For example, the open source framework named as Spring Framework helps to implement dependency injection in Java. If you want to try this example, create a new Angular workspace, create two components, include the newly created components in app.component.html, then include separate files for the three classes in src/app and complete the coding in class A, class B and class C. Then inject the class A in the constructor of component 1 and component 2. Finally, check if the console contains the logs as expected. In the next video, we will look into more specific details about Angular service.